everyone, and welcome back to the Learn Software Development video course. Today we are on our 7th video, and we're going to continue off from where we stopped last time, which was in the Hello World project, where we printed to the application itself using a label node. And now we're going to continue looking at integers and variables. And I'm going to introduce the button node as well to do that one. So let's go back to the project. So yeah, as you can see, I'm starting right off here. Anyways, I'm going to go and find my application, which I've started here. You have it wherever you have it, but Godot 4.01 is what I'm still using now. Haven't checked if there's a new one out yet, but for today's video, I'm going to be using this one. All right, here we have Hello World. I'll double click this to open it. And there, everything should be right where we left them. Label, it's there. If I play, Hello World, it's alive. Great, everything works. So what we are next going to do is we're going to add a new node here. And that node will be the button node. So I'm going to go on top of control, right click, and add child node. From here, under control, we'll have base button, which works as the base class for any buttons that are here in Godot. So here we're going to select just the basic button. So there's other things that inherit button, but we'll just take button for now. And let's create that. Now it's again a teeny tiny thing here. You can scroll into it with the mouse's scroll wheel, or press these zooms here, plus and minus to zoom in and out to get it a bit bigger. As you can see, it's very tiny. So let's make it larger so that it's easier to see and move around. And now with the middle mouse button, I can drag this canvas around. Middle mouse button is either a separate button on the mouse between the left and right clicks, or it's in the scroll wheel. In mine, I have a separate button, but in some other mice, it's in the scroll wheel. There, I can now drag this around, move this around. The label is somewhere here. Let's select it to see. Yeah, let's put the button here about the same. If I hold shift down and then select these nodes, then I can get them both selected, and then it'll show me their outlines as well. So I'm just going to move this a teeny tiny bit here, a bit more. Somewhat aligned with the label. No particular reason why, but just feels nice. All right, if you want to drag, Control Z, don't want to drag that around. Okay, so now that we have the button in place, what we're going to do to it is we're going to add a script to it. Before we do that, let's actually rename this one. So we know it's a button, but let's make it more meaningful. Let's call it counter. Yeah? Because it's going to be counting how many times we press it. All right, and the icon is still that it's a button. To be even more descriptive, we should actually call it counter. Oops. Button, like so. Okay, and now we're going to attach a new script to it. So we'll leave the Hello World script attached to label. Let's leave it as it is. And now we're going to make a new one. So attach script. It's going to inherit button. That's correct. And we'll just make this snake case. So have everything lowercase and then every kind of word separated with an underscore. This is called snake case. Don't exactly know where that name comes from, but that's what it's called in the software industry. Create that. Now we have counter button, and if we hover over this icon here, it shows that counter button is attached to counter button, correct. We don't need this thing for processing something in every frame. If we were making a game, for example, then we'd use process quite a bit, but not in this event-driven user interface. So now that we have this ready and initialized, what we want to do here first is, actually let's put pass back there, is create a container for the data we are going to be counting. So that means we're going to now create a variable of the type integer, and we're going to initialize it, so have an initial first value for it, and have that start from 0. So it'll show how many times we've clicked the button. So when you start the program, it will be 0. So the way you do it in Godot is, and in GDScript, is you type the keyword var for variable. And here you can see also there's var, then space, and then the name of the variable. We're going to call this counter. Makes sense. And I'm going to put underscore because I'm going to keep it within the scopes of this script. It's not going to be exported to any other script. No one else is going to access it. But more on that later. But you can see here also this underscore ready. Underscore denotes that this is private to this script, and nothing outside the script is expected or should access it. I'm not entirely sure if GDScript safeguards against it, that it's not possible. Probably is possible to call those things nonetheless, but this convention does at least tell other programmers and yourself that, hey, the intention of this is to be private to this particular script. So we're going to put underscore counter. Then we're going to tell what type of variable it is. This is the static typing thing. If we just put counter as 0, then GDScript will infer. So it will make a prediction. It will infer, not quite prediction, but look at what is assigned and then analyze the contents and say, oh, this is an integer. So what we need to do here to make it static and make our intentions absolutely clear is to put colon int. And this is enough. We don't have to give it a value. We could choose to either initialize it here or then have ready initialize it when it comes to the scene tree. Both should work for our cases. So I'm now going to put counter int is 0. So now that we have this, then how do we get this to work? Well, let's start off first by printing the value to the button. Currently, if we save this, Control S, and press play, we're not going to have anything visible in the button. Sure, it'll be clickable and hoverable, and that'll work because that's out of the box behavior by Godot for this button class. But it doesn't yet really do anything. And to see what's actually going on and get some more interaction to it, let's print the text. So the button has a text field as well, like from the inspector. If we go to 2D view and select the button, we have this text. So I'm assuming it's going to be dot text, the property, just like it was here in label. There's the self.text. But we can actually check that out. We can search help. So this has a nice help built in here, and there's actually also a link to online documentation. So this time I'm going to go and look at help. And then here it has all the different objects that are available. Here, all the classes, all the built-in things. are available here. So we can search here button, and it's a class, and we can open this, double click it or press open. All right, now we get the documentation, which is also available in the website online, but open up here in the editor. So we don't have to leave the editor to see documentation. That is really nice. That's not a given in every single development environment. But now we have the description, properties. Let's see, text. Okay, so there's a text, and if we click that one, it'll take us to what it is, and the buttons text that will be displayed inside the buttons area. Sounds like exactly what we want. So let's use that. So I'm going to go here, and then go self.text is equal to counter. Maybe that'll work. No. Aha. Well, I knew this won't work, but kept you in suspense. A value of type int cannot be assigned to a variable of type string. So this is integer, this is string. You can't assign them. They have to be of the same type. So how do we get integers to strings? Well, now I'm actually going to go to the online documentation and have a look around. So let's click that button and see what it does. Okay, it opened the documentation straight for me. And let's have a look at strings. How should we get started? Let's check the getting started. Scripting languages. Let's see. No, manual. Scripting manual sounds promising. Programming languages, GDScript, getting closer. Style guide, warning format, strings. Okay, this is the thing we're looking for. GDScript format strings. Okay, GDScript offers a feature called format strings, which allows reusing text templates to succinctly create different but similar strings. Okay. We are waiting for that. Okay, so this is what we are actually looking for. And then there's different format specifiers. There's a lot of things. I've actually read through this previously, so I know what I'm looking for. And this is the table that I like here. So we can give a dictionary in and assign that, hey, this value here, we'll get it from here. So we're going to use the dictionary key style to get our numbers and values put here. So let's go ahead and try that one out. So what I'm going to do here is take this counter away, put in quotes, and then I'm going to put in braces. People call these curly braces, curly brackets. The real name is just braces. These are parentheses, not brackets. These are brackets. Not square brackets, just brackets. Parentheses, brackets, braces. Okay. So inside braces, inside these quotation marks, so this is a string, we're going to now put counter. Then this is in itself a string literal. And if we just now saved this and pressed play, we'll have this exactly printed out. Like so. Not quite what we wanted, but we're getting there. Now, string objects have a property or have a method called format. So, which is this one here. So as you can see, here's a dot, which accesses a member of this object. So this is a string object here, and it has a format method. And we know it's a method because it has parentheses inside which the rest goes. Don't worry, a lot of new things here, and we'll go through these different types later on. Maybe another good theory part would be to introduce the concept of dictionaries in detail, now that we've shown it here in practice. But let's go to here and put formats. Here we can see that it's already suggesting here that we can use format. So let's double click that. And now here, the way to use the dictionary was to, instead of putting the braces inside strings, we're just going to put them directly here. Now it's a dictionary. And then we give it a key. Dictionaries contain key value pairs. You have a key which accesses it, much like a glossary or an index, the word in a dictionary. And then after that, you have the explanation of what that word means. So the key is the word itself. You're looking the definition for, and then the definition is the value. And that's the idea that's in dictionaries. So now here, for us to tell that this counter should be replaced with a value instead of this text we have here, we give the key, which is defined already here as counter, and then we put a colon, and then we give the value. And now here we can put counter, our variable. So what this does is counter is replaced with counter. Okay, there's a lot of counter going on, so let's make this a bit simpler. Let's put here x. And now we'll put x here. So now the x here gets replaced by the value of what's assigned to x inside this format method. I can now demonstrate it. If I press play, we should get 0, which is the value of the counter variable here. And there, it's 0. It's going to get updated, but it's 0. If I were to put y, for example, here or here, but they're not the same, then I believe we'll have some sort of error. Let's see. Nope, not error. We'll just get x printed. Yeah, because it's not being formatted. I do personally prefer to use like full names also for these keys, especially if there's lots of them, to give it a meaningful thing if it's a longer string. But for this sake, x works fine so that we get it separated from counter and you guys don't get so confused as to what's going on. All right. Now I could, of course, put here self.text or self.counter, correction. And this will now be still referring to this counter here. So I don't have to put self.text. I can just put text and that would work. Now I'm just showing this to show you that it works, or then I can have this as text. The self keyword is not something you have to use to access member variables, member attributes, and properties and methods of whatever you're inside. It'll still work. But what I like to do is that if I'm accessing something that I can't see inside the script and it's a member of button, then I'll put self. That is easier for me to notice that, okay, I'm accessing something that's inside here, but because I'm using self, it means I haven't declared it inside the visual scope of what I'm seeing. And here I don't put self just to hint to myself that, hey, this is something that you can actually see inside this file and it's not something that's hidden away inside another class. We'll get to those classes and inheritance things later on. But just wanted to demonstrate this, why I'm doing it like this. So why there's self dot here and why not here. Both work either way. Some could say it's a bit confusing that both things work, but I think it's just flavor. It's an option and you get to use your own style more when you have more options. It's not that confusing, but it gets a little confusing maybe if you're reading lots of code made by other people. But I don't do that a lot, and I think this convention for myself makes sense because it's hinting me to look at this file, and here it's hinting me to look at somewhere else, like inside the thing that we are extending from. So then I'd go to documentation, for example, or if it's a class I've created myself, I'd check it out. Okay, enough about that, moving on. So now we have the value of counter here. Great. But how do we now get the button to actually count something. That was something that we were supposed to do. Now this is just a constant number. We might as well put const here instead of var. Well, what we need to first do is create a function for counting. So we're going to put here 2 empty lines, write func to create a new function, and then here we're going to put count. Let's call it increment, meaning we'll make it higher. And we're actually going to hint that it's not returning anything. So functions and methods, same thing here. Now they return values or they return nothing. So if nothing is returned, you put void. So here in ready, it's not returning anything. So type hinting this would be void. This is the static typing thing. So here we're saying that counter is of type integer and the ready function returns a value and it's actually void. We'll get to functions more in detail and actually seeing functions return values later on as well. But I already want to introduce this concept to you guys. Okay, so let's now get on with the function creation itself. So what we're going to do here is that whenever this increment is called, this function, we're going to increment the value of counter. So what we'll do here is now go underscore counter plus equals 1. And that's all we need to do there. And then we want to print that data also out to the button that it's been incremented. So what we're going to do is copy paste this, Control C, Control V, and then have it printed here. All right, and that'll work. Now increment isn't being called anywhere, but we can test it quickly by calling here increment. And we can actually comment this out. Comments, if you remember from an earlier video, is something that is for just us humans when we're editing the software and something that is emitted by the program itself when it's reading the software. You do that with a hashtag here in GDScript, and usually you put a space after it to kind of make it nicer visually. I believe there's also a Control K option here in the scripting editor that does the commenting itself. Yeah, as you can see, there's a little hashtag here. And you can select multiple lines like Shift, holding down Shift and selecting lines with the arrow keys or with the mouse, and then Control K, and it'll put hashtags to all of them, which is nice when we get into further development. But let's now comment this out, save, and play. So what should happen now is ready, which is called when the object gets first brought into the scene, is called, and it calls the increment, which the first updates the value of counter by 1. I'll show this to you soon. And then it prints it. So what we should have instead of 0 now is 1. All right, but we haven't clicked it, and clicking it does nothing, but we're getting there. So the increment function in itself seems to work. But how does this work? So this is just syntactic sugar to make things a bit more appealing visually, and you don't have to repeat yourself as much. It's the same as doing counter is counter plus 1. So I commented that out. So writing it like this will have the same result. Let's test it out. It's 1. So what's the benefit of this? What's actually happening here? So if we look at this one, we have the counter variable, and we're assigning it whatever counter had already previously plus 1. So we're doing a little maths here. Anything that's on the right side of the equals sign, of the assignment operator, this is evaluated first by the computer, and only after that it gets transferred and stored here. So when the code line is red, the computer first goes, aha, I see counter. Well, what does it currently have? Well, it currently has 0. Okay, well 0 plus 1 is 1, and then it remembers that and stores that value here. This line above, so if I comment this line and uncomment this with Control K, here this plus equals means exactly the same stuff as here. It's just a shorter way of doing it, and there's less repetition of the variable. So it's a bit easier on the eyes once you get used to that one. Also, a minus equals does the same thing, so it's counter minus 1 in this case. I believe also multiplication works and probably division as well, but I haven't really tried those out here in GDScript. But we're going to use the plus equals, so that means if I put plus equals 2, it'll be now plus 2. You get the picture, I hope. So let's take this line off. But now that we have this working, we actually don't want to increment first here. We still want it to be a 0. So if I press play now, it's 0, but it's not doing anything. So now we come to the next thing that we need to do here in Ready. Here in Ready, what we need to do is create a link from this button object back to itself. The button node has a thing called signals. So let's go and see that. Here we have properties. Let's see. Doesn't have signals here. Let's see, inherits base button. If it doesn't have, then there's signals here. All right, so base button, which is the parent class of button, has signals. And these are the things that are emitted. We'll get to the theory of this later. I like to first introduce something, do it, see it working, and then explain the theory. So pressed signal is sent, so it is sent or emitted when the button is toggled or pressed. This is on button down if action mode is button press, and button up otherwise. Yeah, so we're good with just getting this pressed by the default behavior for now. All right, now, because base button is the parent class of button, button will have the same properties and methods and signals this one has as well. So let's go back to our counter button and now connect the signals. This signal behavior and how to attach them is actually different in Godot 4 when compared to Godot 3. So I actually need to check out from documentation how it's done. So I remember seeing signals earlier on when we were scrolling this, getting started, using signals. And then there was something connecting a signal via code. All right, so here there's some about this timer node. Call the connect method, okay. Let's see. Timer.timeout.connect on timer timeout. Okay, so here we have the object, the instance, and we're connecting this timeout signal to this function. Okay, yeah, here it says the line, this line reads like so. We connect the timer's timeout signal to the node to which the script is attached. When the timer emits timeout, we want to call function on timeout. Okay. So we're going to use this to help ourselves. So we have the button itself, so it's called self. So we'll put self dot pressed, and here it has this signal icon, this emitter radio signal outbound kind of icon. So pressed, oops, pressed. And then here it's already giving us different kinds of functions we can put or whatever. We have this increment that we want to place here. And now we're going to actually take those parentheses off and just have that one. It's the name of the function. Pressed called as a function, but is a signal. Oh, yes, signal.connect. That was the syntax. So yeah, this one here, .connect, right. Connect is the function, and this signal object instance gets connected to increment. And now, whenever we press the button, we should have this called. So let's try that out. 0, 1, 2, 3, 4. Hey, cool. We have the variable, it's counting how many times we've clicked the button. If I click somewhere else, nothing happens. And if I click down, nothing happens. If I let go outside, nothing happens. Nice behavior. If I let go inside the box, it takes it as I pressed and emits the signal. All right. Now we can make this a little cleaner. Now that the actual logic works, we now have this copy-pasted code. This is not conforming to the dry philosophy of software development. So do not repeat yourself, or don't repeat yourself, DRY, also known as dry. Kind of nice, keep your code dry. Means don't repeat yourself. And now we are clearly repeating ourselves. So how do we solve this? Well, we can create a function called print. So let's make func print, call it print counter. And this doesn't really return anything, it just sets the value. And now we can copy paste this. And then here we have print counter, and here as well, print counter. And what I'm doing there, by the way, when you saw me not type the whole thing to the end, is the editor suggests these different things, and you can use the arrow keys and then press tab to auto complete it. So I go print counter and suggesting the correct thing there as the first option, so I just press tab. So now we're first calling this function, setting the value of text to the value of counter. Counter is first initialized to 0, and then we're doing the same thing every time it's pressed. So because we're connecting it, so then this background logic of the engine knows whenever this is pressed, this should be called, and it'll increment the counter value by 1, and then again call this. And that's how it works. So let's try that function out, and it works. Okay, cool. Well, how do I know how things work, like really? Well, that's something I can demonstrate with the debugger. So I'm going to now put a red dot here. If I hover to the side here, this is called a breakpoint. Now there's a red dot, looks like a rec button, recording button. It's a breakpoint. And this is used in the debugger. And I'm going to put a breakpoint here as well. All right. And now I'm going to play in debug, run the project, and this is the debug thing that I mentioned earlier a couple videos back. And it should stop here at this breakpoint. And then we can actually see what's happening here. We have this debugger down here. So we're going to utilize this now. Let's try that out. I think it works like this. All right, so here. Now, what's going on is that we have the hello world debug, but nothing is yet visual here. That's because this whole execution of that program is being paused right here on this line. So here we have the print counter, and now we have these different controls, skip breakpoints, copy error, step into, step over. Now step into and step over and then continue, which is like continue until the next breakpoint, or yeah, next breakpoint or breaking point if an error occurs. But step into and step over are very common in all debuggers in many different programming environments. So what we want to do is we can go into this print counter and it'll take us here, and then it'll print the text after that. So let's go step into, and now this yellow arrow line and this highlighted line came here. So it hasn't yet executed this. If we go here, we don't see anything yet. And now if we go step into, it'll take us out of it because we don't have any of our own code to look at. And now it's going to this connect thing. So it was here, went into set the value of text, came out, back out of the function. So it returned out of the function, back to this line of code. And then it's saying execution resumed here. So, all right, we are no longer in a breakpoint. And now we can see that the program has started up and it's waiting for us to do something. Why aren't we stopping here? Why did we stop here and not here? Well, ready is ready is called whenever the node enters the scene. So whenever this button or this label, whatever it is we're dealing with, enters the scene. So that's always called once and only once, and that's guaranteed. Increment is called only when this pressed signal is emitted from this. So it's not emitted now, so we don't get to that. But we'll get to this breakpoint here in this debugger when we click this. And now let's do that. There. Okay, and now what we can do here is look at self, which is the object itself. That's why the keyword is important. This is the random memory ID or some sort of internal ID for this button. It's going to change probably every time you run the program, so no need to pay special attention to it. It's only valuable within the execution session of the program. But we have the value of counter here. So now it's 0. All right. And now if we go step over, so we don't go inside, we just go on to the next line. So let's select step over. Counter is now 1. So this is the plus equals 1. And then we won't yet see 1 here because we haven't printed. We're waiting to execute this line. We haven't executed it. So once we step into it or over it, it'll execute it. If we now go step into, it'll take us here inside this print counter function. And still, this hasn't been executed. We haven't set any new value to self.text. And we can probably see, can we see the value of text? No, we can't. But if I press that object, it showed here. Okay, well, here it's showing. Actually, text is currently 0. Nice. So this is also live and in line with what's going on. So if we now go again, step into, well, there's nothing to go into, so it'll get out and return out and continue execution. Now text is 1. And it's been updated here as 1. So that's how the program execution is, and it's the flow of things inside here. And now we can take breakpoints off. And now if we click this, did it remember that? Oh, it did. It remembered that breakpoint because it has that stored in memory even though we took them off. So yeah, we'll just stop the debugger from here or close the application from the window itself. Now we take these breakpoints off, press debug or press play, and it opens always in debug here. And now we don't get any pauses. But that's if you want to see what's going on, understand what's happening under the hood on the code you created. And breakpoints and the debugger are really useful for that. So there, we have the counter working, and we have the button working, and we've introduced integers, which are whole numbers. We have introduced a variable that holds integers. We're doing some basic incrementation. We've introduced the button node, attached the script to it, and created 2 of our own functions and formatted an integer so that it can be displayed to the button text itself, and connected the pressed signal to this increment function so that we'd have things updated every time it's pressed. And now you are all, and we are all, well into the tracks of getting into some more complex, more advanced programming options in the application. We already have a pretty nice base to create some interactive application. We have a button we can place wherever we want. We have some logic attached to it, some behavior, something that changes. We have a label to print with. I don't know if you guys can see it, but I can see this evolving into some pretty nice, useful application. So let's stop the lesson here. And in the next video, I'm going to talk about some of the theory parts that are going on in here. So I already talked about integers and variables. So what I'll talk about next are functions. How do they work? Why do they work? Why are they necessary? I'm also going to talk about the dictionary here and then probably some class inheritance. I haven't quite decided in what order I'll teach these things, but I'm going to need to give some theory information around these concepts so people can have a better chance of understanding what all this funky looking text here is actually doing. It really does make sense once you understand this concept, so I'll try my best to explain that to you. But for now, we'll leave this here. If the code you wrote looks like this, it should work, and you've attached this counter button.GDScript here to this counter button, which is of type button, and follow the video along, you should be good to go and everything should work just tip-top. Of course, feel free to play around with the size of the button and play around in general if you want, but maybe create a new project and play around there and keep this project clean so that it's easier for you to follow as we go along. But yeah, that's all for today. Thank you everyone for your time, and I hope you guys learned something, and I'll see you guys in the next video. Goodbye.